Hi, my name's Josh. I'm currently away on teaching rounds as part of my primary education course. In advance, I made this video on how to sketch a cubic polynomial, which we have is y equals x cubed minus 3x squared plus 4. Now, beforehand, I factorized using free terms, which that method isn't covered in this unit. It pretty much just means you have to create terms so you can take factors out. The factors we got was x minus 2 all squared and x plus 1. That's going to help us when we find our x-intercepts. So we'll first start with our y-intercept, which is when x equals 0. So if x was to equal 0, we would have y equals negative 2 squared times 1, which equals 4. Therefore, our y-intercept is at 0, 4. We'll just graph that. 4. Now our x-intercept is when y equals 0. So if y was to equal 0, this part of the function has to equal 0, or this part of the function has to equal 0. So basically x equals 2 and x equals 1. X equals 2 and negative 1, I should say. That means our x-intercept is at 2, 0 and negative 1, 0. So we have two solutions for this polynomial. So if it was one solution, it would only cross through the x-axis once. It's got two solutions, so it's like this one, where it's one of the stationary points is on the x-axis, or you can have three solutions, which goes through the x-axis 3 times. So we'll just draw our x-intercepts on 2 and negative 1. So now we need to find our stationary points, which we can already tell it's going to be at negative 2, but we'll just do the derivative anyway. So the derivative of our function, based on our derivative rules, is dy dx equals 3x squared minus 6x. Now we will factorize that, so it will be easy to find the stationary points. So we take like terms, which are 3x is shared by both. So we're left with x minus 2, which you can see that's similar to that one. So now we need to find when the derivative equals 0. So when that equals 0, x has to equal either 0 or 2. So then we know that when x equals 0, that's our y-intercept. So that tells us this is going to be one of our stationary points, probably our maximum. And when x equals 2, we worked that out when we were trying to find the x-intercepts. So we know that this is going to be our other stationary point. So based on it being a positive term for the highest degree of our polynomial, so if this was to be negative, for instance, it would be from the other direction. So it would be like that if that was a negative x cubed, but it's not. So then we can straight away graph it. So let's go there, come up there, and then come down, just touching, and then back up to positive infinity. Alright, thank you for your time and enjoy the rest of your class.